The planet you are standing on is slowing down. Not metaphorically, not gradually over billions of years the way geology textbooks describe. Right now, this decade, at a rate that has not occurred in 3.6 million years. And the force doing it is not a passing asteroid, not a shift in Earth's molten core, not some ancient gravitational nudge from the moon. The force doing it is us. In March 2026, researchers from the University of Vienna and ETH Zurich published a study in the Journal of Geophysical Research, Solid Earth, that should have stopped the world. Using fossil remains of single-celled marine organisms called benthic foraminifera, creatures that record the rhythms of day and night in their microscopic shells, the way trees record seasons in their rings, they reconstructed Earth's rotation speed going back 3.6 million years. What they found was unambiguous. The current rate at which our planet is decelerating has no historical parallel in all of that geological record. Earth's day is lengthening at 1.33 milliseconds per century, and the cause is not natural. It is climate change. But here is the detail that tells the real story. 1.33 milliseconds sounds like nothing. It sounds like a rounding error. It sounds like the kind of number that only matters to physicists with atomic clocks. That is exactly what the people running the world's GPS satellites, space navigation systems, financial trading networks, and synchronized telecommunications infrastructure used to think. They are not thinking that anymore. To understand how we arrived at this moment, and what is already breaking because of it, you have to understand what actually controls the speed of Earth's spin. Earth does not rotate like a rigid wheel. It rotates more like a spinning figure skater. When a skater pulls their arms inward, they spin faster. When they extend outward, they slow. Earth obeys the same physics. What controls the effective distribution of its mass is, in large part, where its water sits. For the last 3 million years, enormous volumes of water have been locked at the poles, in the Greenland ice sheet, the West Antarctic ice sheet, the glaciers of Patagonia, the Himalayas, and Alaska. That water, concentrated near the poles close to Earth's rotational axis, allowed the planet to maintain a certain spin rate. Not fixed, not permanent, but within a range that human civilization has never experienced outside of. Now that water is moving. Ice melt from Greenland and Antarctica is transferring mass away from the poles toward the equator, carried by rising seas that redistribute weight across the ocean floor. The physics is precise and pitiless. Mass moving toward the equator increases Earth's effective radius at its widest point, the equivalent of the figure skater extending their arms. The planet slows. The Greenland ice sheet is currently losing approximately 280 billion metric tons of ice per year. Antarctica is losing approximately 150 billion metric tons annually. That is 430 billion metric tons of polar ice converted to ocean water every 12 months, spreading across the globe's lower latitudes, shifting the planet's center of mass millimeter by millimeter in a direction that every physical law governing rotating bodies says will cost rotational speed. And the researchers found something more alarming than the current rate. They modeled what happens next. Under a scenario of continued greenhouse gas emissions, not the worst case scenario, a moderate one, the rate of day length increase could reach 2.62 milliseconds per century by 2080. That is nearly double the current rate. And unlike the moon's gravitational drag, which has been slowly lengthening Earth's day for billions of years at a rate of roughly 1.4 milliseconds per century, this new climate-driven force is accelerating. The moon is a clock ticking at a known, predictable speed. What climate change is doing is something the planet has never experienced in any period relevant to modern human systems. It is an interference pattern no engineer designed around. Here's the problem that is not making headlines. Every GPS satellite orbiting Earth is calibrated against an expected rotation rate. When you navigate with your phone, when a cargo ship plots its course, when a military drone locks onto a target, when an autonomous vehicle reads its precise position, all of it is built on assumptions about how fast Earth is spinning and where exactly the surface is relative to the satellites above it. A planet rotating slightly slower than its models predict means those assumptions accumulate error. The International Earth Rotation and Reference Systems Service already issues what are called leap seconds, periodic corrections inserted into global timekeeping to compensate for rotational irregularities. Since 1972, 27 leap seconds have been added. The next adjustment is coming. But the system for managing these corrections was designed for a world where rotation varied within historical norms. What happens when the deviation accelerates beyond the buffer the system was built to absorb? In 2023, Meta published an internal engineering paper warning that a negative leap second, a second removed from global time to compensate for rotational fluctuation, could cause cascading failures across distributed computing infrastructure. Facebook servers, Google data centers, financial exchange timing systems, and power grid synchronization all operate on assumptions of time continuity that a single second correction can shatter. A software engineer in Silicon Valley described the prospect as the Y2K problem, except we can't predict the date. That was in a world where rotation was considered stable. The March 2026 findings describe a world where it is not. But the disruption to technology is only the visible layer of a deeper systemic failure. Dig further, and you find that every model of sea level rise used by coastal planners, every flood zone map issued by FEMA, every insurance actuarial table for coastal property, every infrastructure investment decision made for Miami, Jakarta, Mumbai, Shanghai, and Amsterdam carries a silent assumption that the rate of mass redistribution across Earth's surface is predictable. The new research does not just warn that days are getting longer, it warns that the process driving it is accelerating in non-linear ways that compound with every additional fraction of a degree of warming. The planet's own rotation is now a feedback indicator, a measurement so fundamental that its deviation signals something has gone wrong at the level of Earth's physical operating system. And here is where the story expands beyond rotation. The same mass shift redistributing water from poles to equator is doing something else. It is changing the stress on tectonic fault systems. Ice sheets are not passive. They are enormous weights pressing down on them. Crust. When Greenland loses 280 billion tons of ice per year, the bedrock beneath it rebounds, a process called isostatic rebound, rising at measurable rates, altering the pressure geometry of fault lines across the North Atlantic. Scientists in Iceland, Scandinavia, and Alaska have already documented acceleration in volcanic and seismic activity in areas where glacial retreat has reduced crustal load. The 2010 eruption of Eyjafjallajökull, the increased seismicity beneath Vatnajökull, the recent mapping of fault activation beneath retreating glaciers in Alaska. None of these are random. All of them connect to the same shift in mass that is slowing Earth's rotation. The planet is not responding to climate change in isolated pockets. It is responding as a system. The rotation, the crust, the seafloor, the fault lines, the atmosphere, they are all coupled. Pull one thread and every thread moves. The study's lead author, Mustafa Kiani Shavandi of ETH Zurich, framed the finding with a precision that strips away any ambiguity. The current increase in day length is unprecedented in the past 3.6 million years. The primary driver is climate change. The process that caused it is the melting of snow and ice in polar ice sheets and mountain glaciers, and the resulting increase in sea levels. The math has not changed. The mass redistribution is not reversing. Even if greenhouse gas emissions were reduced to zero tomorrow, the ice that has already melted has already moved. The water has already spread. The slowing has already happened. What remains negotiable is only the rate at which it continues. But emissions are not being reduced to zero tomorrow. Under current trajectories, the oceans will continue absorbing mass from the poles at accelerating rates through the middle of this century. The day length change, which feels like an abstraction, is in fact a ledger, a running total of every ton of ice that has joined the ocean. Every day that passes without. A course correction adds another entry. The total is already a number not seen in 3.6 million years. And the next entry is being written right now. Think about what it means that the planet's rotation is our most reliable clock, the mechanism against which every other timekeeping system in human history has been calibrated. Civilizations did not just use the Earth's rotation to tell time. They used it to plant crops, navigate oceans, coordinate armies, synchronize trade, and build the entire technological infrastructure of the modern world on top of an assumed constancy. That constancy is now measurably, verifiably, scientifically ending. Not in a way you will feel in your body, not in a way that will make your morning commute different tomorrow, but in a way that will require every system built on the assumption of a stable rotating Earth, from GPS to global finance to coastal planning to seismic risk modeling, to eventually acknowledge a simple, irreversible fact. The clock is changing. The planet is not broken. It is responding to the physics of what has been done to it with the same indifference it has shown to every force that has ever acted on it across 4.5 billion years. The question is not whether the physics will hold. It always does. The question is whether the systems we built on top of it were designed to survive the moment the assumptions ran out. We built a civilization around a planet that spun at a certain speed. That speed is no longer certain, and the ledger keeps running.